Mm. Good evening, Brave New World. The following video is going to be a different kind from the ones I have recorded in the past. You see, right now I would like to share some knowledge rather than share some history, some stories of horror and despair. This is going to be a video blog in a way that it's going to be done by me, of course. However, the lines I'm about to mention and read were not written by me, but were written by the great writer and biochemist Isaac Asimov. Mhm. I'm going to share some knowledge from Isaac Asimov using the Guide to Earth and Space. How was the moon formed? What makes the wind blow? And stuff like that. A lot of questions are answered in this book, which is a rather must have for anyone who wants to study a little bit, who wants to know a little bit of space, for anyone who wants to know a little bit of astronomy, and for anyone desiring to be something resembling an astronomer an astrophysicist, or anything related to physics and space. So, the question that I would like to share with you today is the number 38. What is the mass of the moon? Should there be any physicist or astronomer or any astrophysicist, physicist, not physician, in the comments below, please do correct or give an answer to that question. What is the mass of the moon? Even if an ancient astronomer were willing to accept Hipparchus' view of the moon and to think of it as a huge world, he might argue that heavenly bodies were composed of pure light and had no substance. Their size might be no more important than the size of a cloud or a shadow, for instance. It would be important then to determine the mass of the moon, how much matter it contains, so to speak. But how can you do that? You can't weight it or exert force on it to change its motion, any more than you could in the case of the Earth. Nor could you go to the moon, not until 1969, to measure what? Well, to measure the pull of gravity on its surface and determine its mass in that way. Going directly to determine the mass. That would be fascinating though. What you could do though is to measure the pull of the moon's gravity, assuming it has any, on the Earth itself. To work on that answer, let's think about a seesaw, something we can visualize. Imagine a long flat pole pivoted over an axis, with a youngster sitting on either end. One youngster is down, with its feet touching the ground. He kicks so that his end of the board flies up and the other goes down. When the other youngster reaches the ground, he kicks and the motion is reversed. This can be kept for as long as the youngsters wish. But suppose one youngster is much heavier than the other. The heavy youngster can kick at his end of the seesaw, which would then go up a bit and come down again. For the weight of the light youngster would not be enough to bring his end down and keep the heavy youngster in the air. The seesaw wouldn't work in that case. The trick would then be to balance the seesaw at a point nearer the heavy youngster. The nearer the pivot is to the heavy youngster, the more difficult it is for him to keep his end down, and the easier it is for the light youngster, far from the pivot, to do so. Finally, a place is found for the pivot that lets each youngster have an equal ability to bring his side down, and the seesaw is back in balance. If you weigh the youngsters and measure the distance of each from the pivot when the seesaw is in balance, you will see that if the heavy youngster is twice as heavy as the other needs twice the length of seesaw than the heavy one does. In fact, if you know the weight of one youngster but not the other, then if you measure the length of the seesaw on each side of the pivot when it is in balance, you can calculate the weight of the other youngster without actually weighting him. This is the principle of the lever, which was first worked out in full mathematical detail in about 250 BC, before Christ, I suppose that what it means, by Greek mathematician Archimedes, 287, from 287 to 2212 BC. 212 BC. Let's continue. The situation of the Earth and the Moon is something like that of the two youngsters on the seashore. The seesaw, sorry. It's seesaw. The Earth's gravity pulls at the Moon, so that the Moon revolves around it. The Moon's gravity, however, pulls on the Earth, so that there is also a tendency for the Earth to revolve around the Moon. About the Moon, sorry. If the Earth and the Moon were exactly equal in mass, then the two tendencies would be equal, and the Earth and the Moon would each revolve around about a point halfway between the center of the Earth and the center of the Moon, with each body on the opposite side of the orbit from the other. But if the Earth is more massive than the Moon, then the point about which both pivot, the center of gravity has to be closer to the center of the Earth, just as the pivot of the seesaw has to be closer to the heavy youngster. The Earth is considerably more massive than the Moon, so that the center of gravity is quite close to the center of the Earth, so close that we can simply consider the Moon to be revolving about the Earth and the Earth to be standing still. Nevertheless, the Earth is not standing still. It's not. And neither is it flat. It has a weird spheroid shape that is not a perfect sphere, but because of the center of gravity of the Earth, all the matter gathers around it. Nevertheless, the Earth is not standing still. It is making a small circle about the center of gravity each month, and the center of the Earth is always on the side of the center of gravity that is away from the Moon. You can tell the size of the small circle the Earth is making each month by studying the motion of the stars in the course of the month. As the Earth makes a small circle each month, the stars seem to make a small circle in the opposite direction. The center of gravity of the Earth-Moon system is 81. So one more time, the center of gravity of the Earth and Moon system is 81.3 times as close to the center of the Earth as to the center of the Moon. The center of the Earth-Moon system is about 4,700 kilometers, which is equal to 2,099 miles. Thank you so much, Mr. Asimov, for writing this book using the metric system. Suck it up, Americans. Your system is horrible, doesn't make sense, and I would say that you are insult here, but no, that's too much. It's just confusing and it's idiotic. That's it. Your system. Also, this also means that the Moon has a mass that is 1/81st part or 1.2% that of the Earth. That may not sound like much, but it still makes the Moon mass 740,000 billion kilograms. What? That's a lot. Yep, that's a lot. Furthermore, because the Moon has a smaller mass, it is also a weaker gravitational pull. You might think that if we were standing on the Moon, we would have only 1/81.3 part as much weight as we have on the Earth. But we must remember that because the Moon is a smaller body, it was an insect. My coat. Ew. I killed an insect on my coat. You might think that if we were standing on the Moon, we would have to... But we must remember that because the Moon is a smaller body, we would be closer to the Moon's center than we are to the Earth's center on Earth's surface. That raises the Moon's surface pull, so that if we were standing on the Moon, we would have 1/6 of the weight we have on Earth. It's almost finished. Once we have the moon's mass and know its size, we can calculate its density, which turns out to be 3.34 grams per cubic centimeter, only 3/5 that of the Earth. From this we can deduce at once that the moon doesn't have an iron core as Earth does, but must be rock all the way through. Furthermore, since the moon is smaller than the Earth, its central temperature is lower than that of the center of the Earth. And since rock doesn't melt as easily as iron does, we are safe in assuming that the moon does not have a liquid center of any kind. Without a liquid center, there is nothing at the moon's core that could swirl, and even if there were, the moon rotates far too slowly to set up those swirls, so we can conclude that the moon has no magnetic field. When probes were sent to the moon to ensure its magnetic properties, it was discovered this was correct. The moon, unlike the Earth, is not a magnet. Wow. As for other planets, Mars rotates fairly rapidly, but it too lacks an iron core. Mercury and Venus do have iron cores, but they rotate very slowly. The result is that these worlds are not magnets either. Mercury shows a tiny bit of magnetism, which is puzzling. And that's it, Brave New World. This is the end of the question number 38. Yes, this is the end of the question number 38, written in this wonderful book written on the Isaac Asimov's Guide to Earth and Space. That was the question number 38. What is the mass of the moon? As you could hear over there, not only does he give a usually small sermon, some kind of background in order to provide a lecture to give on the subject that he's talking about. That was the video blog of today. We'll see you tomorrow, Brave New World. We'll see each other tomorrow, Brave New World. Have a wonderful night and enjoy your sleep.